Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shamsuri bin Kamaruddin. I will present my BSM2, Development of Verification System for Gas Exchange by using barcode scanner with PLC. First of all, I would like to thanks to my supervisor for giving me a guidance in completing this project. Synopsis of the project. This project focused on a case study from TDK Electronic Malaysia. So this feasibility study has been focusing on process inspection and verification of gas exchange. It is because the process of gas exchange is manually performed by operators. The problem is the process of inspection and verification of gas exchange are non-foolproof and not reliable. So possible automation system and design software will recommend to boost the machine performance. Problem statement. As we can see in this picture, only port seat is used to connect all 9 gases. So operators are required to unplug the hose to change to another gas tank. So it's not relevant. And then operator identify type of gas only based on the sticker on the gas tank. Also, it's not relevant and non-foolproof. And the gas tank position inside the gas cabinet are not fixed. Next, operator need to travel from production line to gas storage to take the gas for gas exchange. Objective of this project is to identify the possible improvement for verification system of gas exchange process, to develop a verification system by using programmable logic control (PLC) by integrating with barcode system to verify the performance of the developed verification system. The methodology of this research project is applying the operation of programmable logic control (PLC) integrated with a barcode reader to model an automated gas exchange system. And then a laboratory test is applied to simulate the overall system. After testing the overall system in the laboratory, the gas exchange system will be implemented in real operation in the industry. For the project planning, first study on machine process flow, perform a data collection, define the problem, create a solution for the problem, design mechanism and PLC programming to operate the system, test the design system, monitor and measure the result of improvement, assess and conclude the operation result. So this picture is a concept design of verification system and cabinet concept. So first we have the tower lamp, pneumatic valve, and solenoid valve manifold to control the valve. And then we have a 9 pilot lamp as an indicator to indicate the line gas tank. Next is sequence of operation. For initial condition, as we can see in this picture, first picture, initial condition, red tower lamp will on if the start button is not pressed. So this process to indicate that the push button is not pressed and no process running. And then second, press the start push button to start the system. After press the start push button, tower lamp will turn on yellow, so it will alert the worker for scanning barcode. Then scan the load traveler. Scan a load traveler to indicate which line is to scan. And then number 5, identify which line is to scan. So operator are required to travel to bedside of the machine and look at inside the cabinet to verify, to identify which one line is to scan. Number 6 is scan gas tank barcode, and then scan the port barcode. And if all the barcode tally, the system will start, and then the tower lamp will turn to yellow. For the laboratory test, for the input, barcode reader is connect with PLC by using RS232 serial communication. And write and read program also use RS-232 serial communication. Push button at 00 to start and stop the system. Then tower lamp is connected with output Y00 to Y001 and Y002. Then the pilot lamp is connected with output Y00 to Y013. And for this laboratory test, valve actuator is excluded in this test. It's because due to cost limitation. Hardware and equipment. So for the demonstration, I use 24 volt DC power supply, FX3U48MR PLC, barcode reader RS at 200 series, RS-232 serial communication cable, pilot lamp, and push button. So as a conclusion, the development of the project applied the integration of Mitsubishi FX3U PLC with a barcode system to model an automated verification system. So the laboratory test show a good result with all equipment functional and design ladder diagram for this system work as desired. So the challenge in this research project is automated verification system need a data to register from a barcode reader. Therefore, a basic PLC is not enough and applicable. In this case, it can make it difficult for integration and programming. So the actual implementation will use advanced PLC and a standard barcode reader for the industrial application. Next is the video demonstration.
Assalamualaikum warahmatullahi wabarakatuh. In this video, I will demonstrate the operation of my project, which is verification system of gas exchange. This design will be implemented in actual process. So for this demo kit, tower lamp is replaced by yellow, green and red pilot lamp. So firstly, we need to press the start and stop push button to start the system. In this case, PLC will not process the barcode data until the push button is pressed. The next process is to scan a lot traveler. After scanning the lot traveler, the yellow pilot lamp will turn on to indicate the line according to the barcode on the lot traveler. The process is also same with other. So if we scan a lot traveler for line 2, yellow pilot lamp line 2 will turn on. And if we scan a lot traveler for line 3, yellow pilot line 3 also will turn on. Then I will test functional for line 1. First is to scan a lot traveler. This process is same as before. Scan a lot traveler line 1. Then scan a gas tank barcode. In this case, barcode tag for gas tank and valve are stick on top of layer design due to more clear and easy to scan for this test. Lastly, scan a valve barcode tag. The system verify that all barcode is tally and green tower lamp will turn on. It will indicate that the process is successfully verified. After the operation is complete, press the start and stop push button to release the contact. So the system will stop operating and the PLC will reset the program for the next process. And then I want to test the program and the process whether it's work as desired or not. First, we need to scan a gas tank line 1, and then we scan a wrong barcode by scanning a gas tank and valve actuator barcode at line 2. So we can see what will happen. In this case, nothing will happen because PLC process the barcode data and the barcode data is not tally in the system and will not proceed to the next process. Equipment and device that was used in this demonstration is 24 volt power supply for power up PLC, Mitsubishi FX3U PLC, and RS-232 cable to read a program and use to integrate with barcode reader.